Lesson 21 is going to talk about special right triangles. So in lesson 21-1, we're going to talk about the 45, 45, 90 triangle. So make sure you have the note sheet that goes along with this because I'm not using your Springboard book for today's lesson. Something to write with, a calculator, and your vocab sheet so you can write down these special relationships. Okay, so a 45, 45, 90 triangle is an isosceles triangle. We know it's isosceles because of that theorem that we know if the base angles of something are congruent, then the legs diagonal are congruent as well. So we know a 45, 45, 90 triangle is isosceles. This special right triangle follows a pattern that will allow you to quickly find the sides, even if you only know one side of the triangle. So when they're referring to 45, 45, 90, they're referring to the angle measures inside the triangle. So 45, 45, 90. Now, since it's an isosceles triangle, the two legs are congruent. So let's just call those x. Okay, x and x. The relationship that the legs have with the hypotenuse is the hypotenuse is always going to be x times root 2. Okay, so this kind of shows you little patterns on how to find things as well. But if you just remember this relationship, the legs are x, the hypotenuse is x times root 2, you should be able to find any side length of the triangle. So let's look at some examples and we'll put this formula kind of to use here. So if we look at number 1, we have a 45, 45, 90 triangle. And the hypotenuse is x, our legs are 8 and y. Now again, in this particular relationship, the legs are congruent. So we know both of those sides are going to be the same. So if this leg is 8, so is this one. So y here is equal to 8. Now the relationship with the hypotenuse is always x times root 2. Well, if these are 8 and 8, then this has to be 8 times root 2. So that's all that's saying here, okay? And again, if I look at this is like our x side and our x side and x root 2. That's the relationship that 45, 45, 90 triangles have. So let's look at it number 2. Let's look at this one. So again, our legs, think of those as like x and x. And then our hypotenuse we could label as x root 2. So if the hypotenuse is 10 root 2, what does that make m and n? Because these are both the legs, they're going to be the same thing. So what would m and n equal? Okay, well, hopefully you're noticing that 10 is the coefficient in front of the root 2. So 10 is x. So m and n would both be 10. Okay, let's look at another one that's a little trickier. Okay, number 3. Again, we have our two legs that are going to be congruent. So this is kind of like our x and x. Our hypotenuse is always going to be x root 2. So let's think about what we have here. Number 3. So v has to be the exact same thing as this side length. So I know v is the same length as 5 root 2. Okay. So u has to be x times whatever root 2 is. Okay. Well, x is 5 root 2. So here's how I'm going to find u. I'm going to do this work on the side here. U has to be equal to the x value, which in this problem is 5 root 2, okay, times root 2. So if we remember properties about multiplying radicals, you can only multiply a radical times a radical. So this becomes 5. 2 times 2 is root 4 then. Well, the square root of 4 is 2. So u ends up being 5 times 2 is 10. Okay, so sometimes you have to do a little bit extra algebra to find the missing side lengths. But again, it's always going to follow that same pattern. Okay, where the two legs are your x values, the hypotenuse is always labeled as the x root 2 side. Let's just finish up here with a couple more. Now, these ones are from your book. So if you need to kind of look at them, they're as well. But I just kind of copy and pasted them onto this note sheet. So in this one, all we have to do is find what x is. Okay, so in problem 5, all we know is our hypotenuse here. The hypotenuse is 17. So again, if I kind of label this would be x. X, the hypotenuse is x root 2. So here's how I would set up this equation. I know the hypotenuse, which is 17, is supposed to be equal to x root 2. So to find x, I would just have to divide out that root 2 on both sides. and solve it for x. So right here we have x equal to 17 divided by root 2. Now again, if you remember anything about radicals, is radicals are not allowed to be in our denominator. So I need to rationalize the denominator on this one. So if you remember how to rationalize, you just multiply top and bottom by whatever that radical is. So I'm going to multiply top and bottom by root 2. So this is going to give me 17 root 2 over root 2 times root 2 would be root 4, which is just going to end up being 2. Anytime you multiply a radical by itself, they're going to cancel the radicals out. So just think of like root 2 squared. A squared would cancel the radical. So that's how we can end up with solving for x. So anytime if you're given the hypotenuse and you need to figure out what one of the legs are, just set that hypotenuse equal to x root 2, because that's what the relationship says the hypotenuse should be. Divide out the root 2 to solve for x. Now this one we just had to do a little extra work because the radical ended up being the denominator, and that's not allowed in math. We just had to do a little rationalizing. But if it canceled out, then that's nice. You wouldn't have to worry too much about it, but here we go. Okay, 6 is a similar problem. So we have our legs. So again, it's kind of x, and the hypotenuse we would label as x root 2. Okay, so we would have to take our side here, which in this problem is just 4 root 5. And to find the hypotenuse, we just have to multiply that by root 2. Because the hypotenuse is x times root 2. So that coefficient doesn't change because the other radical doesn't have a coefficient. But root 5 times root 2 would give me a square root of 10. Now, if we could have broken that down a little bit, we should have. But root 10 has no perfect square factors. So we know we're done with this one. So this would be our answer. For root 10. So that would be our hypotenuse. Okay, so I'm going to have you guys try 7. Okay, so 7, they're giving you the hypotenuse is 5 root 12. So you're going to set 7 up kind of like number 5. Where you're going to set the hypotenuse you're given equal to x root 2 and solve for x. So see if you can do 7 on your own. So all you're doing is finding the side length of the leg. Just solving for x here. Okay, here is the work that I got. So our 2 legs here, we have x and x. Our hypotenuse we consider x root 2. So I set that hypotenuse equal to x root 2 and solve for x. So I divided out the radical. Now this one, since 12 divided by 2 simplifies to 6, we don't have to worry about rationalizing because there's no more radical in the denominator. So this problem is done. Our 2 legs would be 5 root 6. Okay, so sometimes the problems are quick. Let's do this full screen. Okay, sometimes the problems are quick and it's just kind of looking at the problem, like 1 and 2 are really quick problems. Sometimes you're going to have to do a little bit of extra algebra here to solve for the different sides. But just remember this relationship. The 2 legs, we would always consider our x's. Okay, whatever that length is, the hypotenuse is always x root 2.